Hello all. Today we are solving LeetCode problem number 3637 Trionic array. So you are given an integer array called nums which is of length n, and we have to find if the array is a trionic array or not. So what exactly is a trionic array? So the array is a trionic array if there exist indexes 0 which is less than p, less than q, less than n minus 1, such that the intervals nums of 0 to p is strictly increasing and the interval from p to q is strictly decreasing, and the interval from q to n minus 1 is strictly increasing. So which is nothing but we start at 0 till p it is strictly increasing, and from p to q it is strictly decreasing, and from q to n minus 1 it is strictly increasing. So if all these conditions satisfies, then you can go ahead and return that the array is trionic. So you can return true, otherwise you can return false. So that is all about the question. So let us understand this by running through the example 1. Right, so example 1, we are given the values 1 3 5 4 2 6, which can be represented in the form in the grid basically. So we have x-axis and y-axis. So where x-axis we are having index values starting from 0 to 5, and in y-axis we have the nums of I values starts from 1 to 6 as it is given in the array. So we can see here that 1 3 and 5, 1 3 and 5, the array is strictly increasing, and 5 is the break point, right? 5 is a break point, and the next to 5 element, which is I plus 1, which is the next element, the array start to decrease. So we can see here it is 4, then it is 2, right? At 2 again you can see the next element after 2, it is again greater than 2, which is nothing but the array which is n minus ith, n minus 1th element, which is increasing. So you can see the pattern here, it is increasing, decreasing and increasing, which is nothing but satisfies this all condition, and you can hence go ahead and return true, right? So also in the explanation you can see they have given an statement here which is that strictly increasing, decreasing and increasing. So from this we are getting an idea of how to write this algorithmically, right? So you can see here first we are testing for strictly increasing, right? And next we are testing for strictly decreasing, and again strictly increasing. So when are we stopping this check? At when we get the breakpoint. And similarly the breakpoint, and again breakpoint. But for strictly increasing there is a different breakpoint, right? And decreasing there is a different condition to find the breakpoint. So here you can see that when the if the ith value is less than I minus 1th value, sorry, this should be greater, I'm sorry about that. When the ith value is greater than the I minus 1th value, then at that point yeah, this should be less than, because this is for the greater than breakpoint, right? So I'm so sorry for confusing here. So if the ith value is less than I minus 1th value, which is nothing but here 5 and 4, right? So fourth it is 4 is less than 5. So then at this point you can say the first breakpoint, which is p, is nothing but 5, which is nothing but I minus 1, right? And we start from 0, right? So from this you can have an observation that if 0 is not equal to the p, I mean p is not equal to 0, or 0 is not equal to 5, right? So in this case you can continue. So if p is equal to 0, which is nothing but if which we can conclude that there is no strictly increasing, instead in this case this will result in decreasing. So in this case you can return false, right? So this is for strictly increasing. Again, for strictly decreasing, we will have to check if the nums of I is lesser than nums of this is less than, right? So this should be opposite, which is nothing but this should be greater than nums of I minus 1. So in this case again the breakpoint will be I minus 1. Let me change the color of ink. So in this case the breakpoint will be I minus 1 again, and again we have to check with this should be P and Q, because the starting point is P and end is Q, which is nothing but I minus 1. So this should not be equal. Then continue, right? So we have done the first check. This is the first check, this is the second check, and again we have to go for the third check, which is nothing but strictly increasing. So we again check for the same condition, which is I'll change the ink. So nums of I is less, if this happens, nums of I minus 1, then breakpoint, and start will be equal to Q, right? And you have new I minus 1. So this should not be equal, and this should be I. Here you should check the I that should be less than n, right? So I mean this should be I n minus 1, I should be n minus 1, right? So if it is less than that, anything less than that, you will return false. So if it is not equal, then you will continue, and you satisfied 3 condition, which is a green tick, and now you can return true, because all the condition for a trionic array is satisfied. So you can go ahead and return true. So now talking about time complexity, this will be big O of n, because we use 3 condition, which will use which we will use while loop. So eventually we will find a breakpoint, which will from 0 to P, and P to Q, and Q to n minus 1. So which will be of total length n, so due to which the time complexity will be big O of n. So with all this observation, let us go ahead and code this up. So first is n is equal to n of nums, and now I we have to start with 1 because we are finding I minus 1. So while I is less than n, right, and you have to check for the condition here, and nums of I is greater than nums of I minus 1. This will run until that, so it breaks, right? So each time you increment I equal to 1, so when it breaks, you have to store the value p is equal to I minus 1, because you have the value of I defined globally and you can track the value. So now if uh, p is equal to 0, return false. This is check 1. Now again you will run this while loop, but for strictly decreasing you have to change this sign, which is nothing but this should be lesser than or equal to, it runs till that, and again you similarly increment the I pointer here, and now you have find a q. Q is nothing but I minus 1 again. Now you check if p is equal to q, return false again, right? So again you will check for the strictly increasing condition, which is nothing but the same one, right? Now you will have the start point as uh, q. So if q equal to the last I minus 1 value, and this should also satisfy this should be, yeah, this should be, or I minus sorry, I should be less than n. If in this case, right, if any one of this is true, this should not, both should not be true. If any one of this is true, then you can return false. Oops, I forgot to add this n. This should be less than n, so false, right? So if all this condition we crossed and we do not encounter any situation to return false, you can return true. Let us run this. Let us submit this. Yeah, there you go. It's an efficient solution. Thank you.